And I am live. That is pretty cool. Today is 5th of October 2025, Sunday, and we can just begin. And I was looking at something. Let me show you. Yeah, here. There is this person, male, female, I don't know. Uh, this guy is currently at a rating of 2300, and that is also something that we want to achieve. And look at how many questions this guy has solved. 26,206, 2,2600. And I have solved 335, a measly 335. So in 3 months, can I even solve 2000 questions? 3 months, let's say 90 days, and let's say we will solve 1300 questions. So to even solve 1000 questions in 3 months, we would have to solve more than 10 questions every day. 11 questions. Yeah, a bit more than 11, at least 11 questions every day to solve 1000 questions till the end of this year. And we are not even close to that mark. Now, like, look at this. I have only solved 61 800 rated problems, and this person has solved 323 800 rated problems. So that must mean something. So yeah, this simply means that we have not solved enough questions and we have to solve a lot more than we have solved till now. Like this is a joke. 335 questions. So this is a joke. We need to get to at least 1500. Can we get to 1500 by the end of this year? That would be 1200 questions more in about a bit less than 90 days. 1200 questions. That is how many questions? 900 upon 1200 upon 900, 1.33. 12 upon 9, 4 by 3 questions every day. Yeah, 90, not 900. Yeah, so yeah, we have to solve about 13 questions every day. Don't give the metric as 2000 plus. I personally know a master at Code Forces which has solved less problems than you on Code Forces, and he is a master quality of problems more than quantity of problems. So I'm not taking this as a like something that would work for everyone, right? You can even find people who have like solved a lot more questions and still are nowhere. This is just something that is going to work for me, I think. And yeah, I will have to solve a lot more questions about. So I can start with solving 10 questions every day, and then I will increase it because nah, he might be like much better than me, but I'm not that smart, so I will have to focus on quantity. I cannot extract. There is only a certain amount of things I can extract from a certain problem, from a singular problem. So by increasing the number of problems, I think I will be like getting more than I am getting right now. Yeah. So when I sit in a contest, it should not be like, oh, what is this? It should be a natural state. While I'm in a contest, that should be a natural state for me to be in. And to make contests a natural state, I would have to solve a lot more questions. And what I've come up with is I will, starting from 1000 level, I will solve at least like 50 questions of 1000, 50 of 1100, then 50 of 1200, and so on. And yeah, and meeting a goal of at least 10 questions every day from today. And in the streams, since these streams go about, no, that today's contest is starting from 10 p.m. and I will be like sleeping by then. So no, not today. And yep, because I need my rating to increase. Yeah, I want to get better at this. And also, since the streams go out for 3 hours and supposing that it will take me for 40 minutes to solve a single question, I should be able to solve at least 4 questions in a stream. And yeah, so with that, yesterday I solved 3 questions and we bailed out on this last question. Yeah, and yeah, let's go. So we will have a timer for 40 minutes, and if we are unable to do the question in 40 minutes, we will look at the editorial, and that would be nice. And this is just the question from yesterday. So let's think about this for, let's say, 30 minutes, and then we will move on to the next question. Or 20 minutes would be nice for this. A timer for 20 minutes, and let's move. Cool, and is Tmux ready? Cool. All right. So we do remember the question from yesterday. There are triplets, just like this. Yeah, this is the exact thing. There are triplets, and I was thinking about this. So what we want from a triplet is to just eliminate the smallest number. And we can have triplets of a few types, a few categories. So first would be, and yes, we are supposing that we have 3 numbers in a triplet, x, y, and z, and there can be a few categories, x equals y equals z. That is, all of these numbers are equal to each other, and another category would be x equals y, only two of them are equal to each other. And in this there are two subcategories. One would be when x is greater than z, in which case you would like to eliminate z, and copy category, or like second subcategory in this would be when z is greater, in which case we just want to eliminate the smallest, where x and y both are the smallest numbers, so we can just eliminate any one of them. And fourth category is x not equal to y and not equal to z, like none of them are equal. And in this case we just want to eliminate one. So let's see here, we can color the vertices in any way we want, right? So yeah, let's say fixed and not fixed. Fixed, where we want to eliminate one vertex specifically. Here we do not want to eliminate any vertex specifically because they are all the same. Here we do want to eliminate the z vertex because x and y are the greatest, we want them, and z is the smallest, we want to eliminate z. And here we can eliminate x or y, anything. We just want to make sure that we get z with any x or y, anything. And here we do want to eliminate the smallest vertex because x, y, and z are not equal to each other. So like two of them would be the largest elements and one would be the smallest, and we want to remove the smallest. And so that much is true, right? Yes. And if we take our, let's now take an example and make some maybe conclusion. And this is probability and stuff. So here we have a couple of, not couple, 4 triplets. This is a triplet. This is one, this is one, and this is one. And we know that the correct answer for this question is, I think 36 is the correct answer. Yes, 36 is the correct answer. And here, how many do we have? Here we have one triplet of this type, not fixed, and in not fixed also we have two categories, this and this. Here, here our arrays, our vertices can be of any color, and here we want to say that Z should be included, and here it does not matter. Here it does not matter. Here at least one should be fixed. Hello, Krito cool. Can you tell me how you check all detailed stats on profile, like which topic you solve? And yes, there is a extension for that. This one, this one, CF analysis, code forces analysis, and this, yeah, this is like pretty cool extension. You can go to a profile, maybe not mine, but Mr. Jiang Li's profile. Look at this loading. He has solved a lot of questions. And to be specific, he is about to solve 7,000 questions. That is crazy. And this is still loading. Yeah, this is the extension you can use. Pretty cool. Yeah, loading. Let's go to my profile. Yeah, it works. I don't know. It is not working right now. Yeah, it is the extension you can add. It is working now. Not here, but yeah, here. This is the extension you can add to see the stats. So here also we have two types. Here these two are equivalent, right? We specifically want to eliminate one, and here also we specifically want to eliminate one. Okay, let's see how many do we have of this category and how many do we have of this category. Here, this is the category for this triplet, so we can increase this by one, and this is like too thick. And here all of them are different, so this is also in this category. Here all of them are same, so plus one here, and here two are same, but the biggest is the one that is different, which is this category. Okay, and this one is in this category and this one is in this category. Okay, and so we have to reach some conclusion with this. Yo, make some hypothesis. And in any given triangle, in any given triplet, this has some weight y and this also has some weight, and since we want to include at least two, let's say this is in color green and these two are in color blue, and since this edge is attached to vertices whose colors are different, this will be added to the final answer, and also this will be added to the final answer, and this will not be added. So this is the value of this triplet. That is what is defined in the question. And we at least know that we cannot color all of these vertices in the same color, because we won't be getting anything out of this. So that is one conclusion. And second is that here this configuration has a same opposite symmetric configuration, you could say, in which everything is same except that these colors are flipped. This green is blue and these blues are flipped. These blues are greens and these two are symmetric. It is just the colors have been flipped. So we can just find a number of these configurations and then multiply the answer by 2 to get all the opposite configurations in which all the colors have been flipped. So somehow we have to get 18 configurations out of this. Okay. And let's deep dive for these categories. When we want to remove one specific edge, when the answer is fixed, let's say when x not equal y not equal to z. In this case, this has weight x, y, and z. In this case, let's say z is the smallest. It can be arbitrary, but let's say z is the smallest, and the two colors we have are red and blue. There is only one possible configuration for this, in which two of the vertices which z edge is connected to, they have the same color. And we are only considering one configuration. Another, the opposite, the symmetric configuration for this would be when we have like everything the same and the colors have been flipped and everything else is the same. So there are, let's say in total, two configurations. Since we want to remove z, these edges must have different colors. These vertices must have different colors, and that is the case when the answer is for all of these fixed configurations. And let's say we only had these two fixed configurations, what the answer would be then. Let's say our triplets are 1, 2, 3, 4, 5, 6. These are our triplets. So they would look like 1, and it is the edges that have weights, not the vertices. 1, 2, 3, and the next triplet is this 4, 5, 6. And here we want to remove 1, and here we want to remove 4. So it's color these red, and this would be red, because in total there are 6 nodes, and to color these 6 nodes we need to color 3 nodes in blue and 3 nodes in red, because the number of red nodes and the number of blue nodes has to be same. This is blue, this is blue, this is blue. This is one configuration, and the another would be opposite, when all the red nodes are switched with the blue nodes and the blue ones with the red nodes. So there would be in total just two configurations for something that is fixed. But what if there were two more of these fixed ones? I, if there were two more of these fixed ones, let's say after 6, 7, 8, 9, this is one triplet, and then 10, 11, and 12, that would be one triplet. There are two independent configurations for these and two independent configurations for these, right? And so should the answer be 4? 2 into 2, 4. But maybe in some case this one is paired up with this one. That is one possibility. Okay, let's say we have 4 nodes, 4 triplets in which are in the fixed category. Merlin AI, shit, AI is talking. How are you so consistent with CP? You also do dev or any DSA? This is DSA, I think. Algorithms are DSA. And to be consistent, just be consistent. There is no trick or anything. Let's say we have 4 triplets which are in the fixed category. In this category, fixed. And okay, we have 4 triplets in such a category. And since we have 4 triplets in total, there are going to be 12 nodes each triplet having 3 nodes, and in total you need to use 6 red nodes and 6 blue nodes. And okay, 1 2 first triplet, second, third, and fourth. First triplet has a choice of using either, let's say we are just talking about the placement of 6 red nodes, because if we know which 6 nodes to color red, then all of the rest nodes would be colored blue by default. So let's just think about these 6. So this one node can have this triplet number 1 can have 1 red nodes or 2 red nodes. The second node, second triplet can have 1 red nodes or 2 red nodes. Same for these and same for these. But when I have used 1 red node out of my total 6 red nodes here, then I have 5 red nodes left, and I can go with 1 here, use one of these 5 red nodes here, and then I will be left with 4, and I must exhaust these 4 red nodes. Therefore I must give them 2 to each. Now that is one possibility. And if I went with this instead of with this, when I had 5 red nodes, then I will be left with 3 red nodes. And here this one could have 1, and this one could have 2 red nodes, or this one could have 2 red nodes, and this one could have 4 red nodes. In total 2 possibilities when I went with 2 red nodes in this, so plus 2. And if we began with 2 red nodes originally, then we were left with 4 red nodes. And among these 4, we have to distribute these 4 red nodes, and the only possibilities these could have are 1 plus 1 plus 2. These are the only possibilities, and I have to divide these numbers among 3 nodes, and they are only distinguished by where this 2 goes. So this 2 has 3 places where it could go, this or this. So in total there would be 3 possibilities, so plus 3, so answer would be 6. That does make sense. Okay, so we can think about this in a different manner. Here we say that we have 6 red nodes that we have to distribute. 6 red nodes that we have to distribute. And in total there are 4 triplets. So these 6 could only be divided in this form: 1 plus 1 plus 2 plus 2. In total these are 6, and these are divided into 4 triplets. That is nice. That is nice. And how can we distribute these 4 things, these numbers, among 4 different numbers? That would be the answer. So this is like permutation, but we have 2 things that are same. Okay, so there is a formula for this, right? When we have some elements which are same in a permutation. Hello. Not a lot. Hello, good afternoon. No, today's contest is like quite late. 10 p.m. 10 p.m. is no, nah. 10 p.m. is a bit too late for giving a contest, but so no. But tomorrow's contest is on the regular time, so that would be cool. Yes. I think there is a formula, not that. I think there is a formula for permutation when we have same elements. Let's try what is the normal permutation formula. We have four numbers and we need to like put them in four different places. So the formula is 4 factorial. Now we have to divide that with 2 factorial and 2 factorial. I think that would be the correct answer. And if we actually do this, and we would get 6. So 2 into 3 into 4 and divided by 2 into 2, that actually is 6. Okay, that is pretty cool. That is pretty cool. That is actually pretty cool. And this is the case when we have different, uh, when we have only triplets of this category, of fixed category. But we might also have triplets or of non-fixed category. And okay, so internally, these would change. Internally, shit, that scared me. Shit, that was kind of scary. Which problem are you solving? This one, from yesterday. Triangle coloring. And I think I got this. The timer just spoke, and that was kind of startling. Okay, so when we have in total n nodes, right? I think we have it. Yeah, yeah. When we have in total n nodes, there are going to be n by 2 red nodes, and they will be distributed in how many triplets are we going to have? We are going to have n by 3 triplets. Yes, we are going to have n by 3 triplets, and yeah. So how many one nodes do I need and how many two nodes do I need? N by 3 triplets. This is the number of triplets, and this is the number of red nodes. And this is even. So this is an even number, so that each triplet is in a pair. I think we just do n by 3 number of triplets, and how many pairs of triplets? We will have n by 6 pairs of triplet, and each pair of triplet has a one node and a two node. So in total, we will have n by 6 occurrences of triplets in which we have only one red color, and same occurrences of triplets in which we have two red colors. And the total number of triplets is n by 3. And we, okay, so the total permutation for these, we need to divide. So in total, we have n by 6, 1, and n by 6 triplets, which have two nodes. So in total, n by 3, and if we do n by 3 factorial, that would be so we can treat this as a string of 1 1 1 1 and then 2 2 2 2, right? And so there are in total this many permutations for this thing, n factorial, n by 3 factorial. And since in this n by 6 are same and other n by 6 are same, we have to do n by 3 factorial divided by n by 6 factorial into n by 6 factorial. And that is nice. Let's say n by 6 equals x. And if we put that there, we should have 2x factorial divided by x factorial into x factorial. Yeah, we just have to calculate this number. That would be the total number of ways in which we can distribute these ones and twos. And internally, we will also keep track of these triplets where all the numbers are same, because in these, whatever the permutation is, there are internally 3 different permutations for this. So whatever the final answer is, let's say that the final answer is capital A, we multiply that by 3 into the number of nodes where triplets where all the numbers are same, S, multiply by things of this kind have 2 different internal configurations, so 2 into things of kind 3. And okay, so here n, in this example, n equals 12, and therefore n by 3 is 6 and n by 6 is 3. And if we do 6 factorial divided by 3 factorial into 3 factorial and into 2 into 3, because we only have one of each kind from this, in total we will have 6 into 5 into 4 and 3 factorial by 3 factorial and 3 into 2, that is another 3 factorial. This should be the answer. It is not. This turns out to be 120, but the answer is not 120. The answer is not 120. We have 6 factorial, that is shit. Yes, shit, we have to do n by 3 is 4, my bad, shit, and this is 2, shit, that was wrong. So 4 factorial divided by 2 factorial into 2 factorial into 3 into 2, 2 what is this, is 4 factorial and into 3 into 2, so this will give us 4 into 3 into 3, that is 12 into 3, 36, which is the correct answer. 36 is the correct answer. So that is nice. That is kind of nice. We can just apply this formula now. Okay, cool. Taken n, and yes, but this n can be very big, so we just do not want to blindly calculate factorial of n. And also division in factorial is very bad. Yes, division in factorial is very, very bad. So we have to find a, okay, let me at least write the correct formula first. We have n, total number of nodes, and r, okay, n is number of nodes, and then we have s triplets where x equals y equals z, and let's say t triplets where x equals y but not equals to z, and z is greater than x, that is something, right? And then our final answer turns out to be n by, yeah, our final answer will turn out to be n divided by t full factorial, n divided by 3 factorial, this thing divided by n by 6 factorial, right? And 3 and 3 into s into 2 into t. That is the answer that we are after. And if s and t are 0, then this thing just becomes 1. We will not replace these terms by 0, so then the final answer is not 0. So that is the final answer. Now we need to find a smart way to calculate this thing. And yes, this thing is like twice. And we do know that this formula is correct. I think we reached this logically. How are you consistent with CPA? And we also do 70. With that is like twice. I have 7 months till IOI International Olympiad in informatics. Also ZIO in December. So 7 months is a long time. 7 months is a very long time. Even if I think you start from 0 and you are giving all of these 7 months to one thing, then you should be able to become really good. So yeah, 7 months is a long time. Just be consistent and you will be good. And how to be consistent is, yeah, I would say something like what Nietzsche said. If you have a strong enough why, this thing. He who has a why for which to live can bear with almost any how. Why do you want to be consistent? You have to decide why you want to be consistent. Something like binary exponentiation, but for factorials. Binary exponentiation works because we can take modulus. We can take modulus with m. When we multiply a by b, this thing, modulus m equals a modulus m into b modulus m total modulus m. But this modulus operator does not work the same way with division. So n can be very big. And if we were to find factorials of n by 3 with some modulus and divide and also find the factorial of this number with modulus and then divide these, this would not work because x by y modulus m is not equal to x modulus m divided by y modulus m. And yeah, so what do we do? What we can do is find maybe the multiplicative modular inverse of y. Let's say y dash is the modular inverse of y, and then we would have x into x dash, and then we can have modulo m. But then, yeah, we will have to solve like Diophantine equation for this. Not Diophantine equation, we will have to solve what, a totient function for m. M is a prime, right? M is a prime. This thing is a prime. How can we know? Yes, it is a prime. Okay. So yeah, this number is a prime. We can find the modulus inverse for y, which is going to be, we can, okay, now we can do this. Now we can do this. Now we can do this. We can find modulo x, right? And we can find modulo y, where y is also a factorial and x is also a factorial, and then we can raise this thing to a power of m minus 2, which would be equal to y dash, that is the totient function, not totient function, that is how we calculate modular inverse when m is a prime number. And this will work. Then we can just multiply x by y and take modulo m. That would be our answer. Okay, let's do this. Okay, and we will also need a binary function with a power, pow, return in, pow takes in a and takes in b and m, and if not b, then return 1, and yes, if not, then answer equals pow a raised to the power of b by 2, comma m, and then answer multiplied by answer modulus with m, and b was if b was odd, then answer multiply by a and answer modulus with m and return answer. That is binary exponentiation. And now for our final formula, this thing we need to find factorial. Let's also write a function for calculating factorial with a certain modulus. Let's also put the modulus that is given to us. Const int m equals this number, and in fact it takes in a number n and a number m, and for int I equals to I less than long answer equals to 1 less than equal to n I plus plus answer multiply by I and answer modulus with m. And there is a faster way. Can we like cheat in this so that we don't have to run a loop again and again? We will only call the factorial function 3 times, so that is fine. Time complexity is still logarithmic, so that is fine. That is fine. Can you see the syllabus of IOI and tell me if I should go with CACS or CP31? Cannot put links here. Wait, with CACS or CP31? I don't know. Okay, so for me, I think learning the thing is more important than seeing where I'm learning from. I look at this CP31 sheet and I see that there is a lot that I do not know about, so just do the sheet, right? And I do not think if, and I do not worry about if I'm getting the best material or not. So whatever there is something you do not know in CSCS sheet, then do that. If there is something you do not know in CP31 sheet, then do that, and do not think about which one is better, right? C++, a nice, complicated, flexible language, and I don't think we can solve this factorial function in better than this time, unless we do some pre-processing and not do this and not call this function 3 times and store the answer beforehand. But this is fine. This is fine. Return answer. And if for your question, just do not think about finding the best problem, finding the best syllabus or best material for learning. Just see whatever it is in front of you and do it, because I think all materials are good. It depends more on you what you're doing with it. And that is pretty nice. And where do you learn topics from? From CP31 and the handbook and CLRS. These are nice things. And editorials of problems, they are nice. And one more thing, solutions by other people. If you go to Mr. Jiangli, and see his last contest, he solved 8 questions, and his third solution for this question. And I was reading this today, and this is much better than the one I submitted. And sometimes, okay, and one more thing. Here I saw this syntax and I thought, what is this? This does not look like C++. Where are the template arguments? And then I came to know about one thing which is called this class template argument detection, I think. Yeah. And yeah, detection or determination, in which if our initialization function here for this variable of type vector, here our initialization says give me two things, right? And these things are of this type, vector integer. So we do not have to give in a template argument is explicitly and say make a vector of integers, because that can be inferred from this part. So we can just, yeah, we can skip the template argument parts and move with this. This came in C++ 17, and yeah, that is, and then I made a YouTube post about this. So that was nice. So yeah, read solutions by other people. That is pretty nice. And getting back to this, the factorial function is cool and working. And now answer is factorial raise n by 6 to with m and long denominator then equals fact. Wait, this is n by 3, n by 6 with m, and now we have this part, we have this, and now we need to find the modulus, um, modular inverse of this number. But before that, then into then and then remainder modulus with m. And now modular inverse of den would be power den raised to a power of uh, m minus 2. That would be its modular inverse, and this. And then the answer, at least for this part, is going to be answer into den. So answer multiplied by equal to, or we can call this inverse as in, just in case we are making this long, multiply by inverse and answer. Yes, now we need to find out S and T. S is the number of triplets where all the numbers are same, and T is the number of triplets where the answer are, yeah, only two of them are same, and the one that is not same is the bigger one. Int S equals 0 and int T equals 0, and vector, we can use this thing that we just saw in Mr. Jiangli's code called template argument, class template argument detection. A, we need an array of size n, and initially every element is 0, and there is no error for this. Int reference x in A, C in X, and now let's go for int I equals 0, I less than n minus 2, because we want always to be there two elements to the right of the current element, and I plus equals 3. Yeah, move to the right by 3. So if AI equals AI plus 1 and we have AI equals a AI plus 2, then S plus plus. These are same. Else, if only two are same, how do we see that only two are same? We know that all of them are not same. So if either AI equals AI plus 1, or let's swap. If AI equals AI plus 1 or AI equals AI plus 2, or they are equal to each other, AI plus 1 equals AI plus 2. When we are here, we know at least one of them, uh, yeah, at least one of them, two of them are equal to each other. And all of them are not equal to each other, because if all of them were equal to each other, we would have gone into this condition. Okay, and now let's say AI is the one which is different, and that we can check if, let's make AI the one that is different. If AI is same, if AI plus 1 equals AI plus 2, this would be the case when both of them are different. When these two are not different, that would mean that AI is one of the elements which are equal to each other, which, yeah, one of the two elements which are equal to each other, and we do not want that. We want AI to be the one that is same. So if, and now we have to see which one is different from AI. Is it AI plus 1 or AI plus 2? And if AI not equal to AI plus 1, then swap AI comma AI plus 1, and else if AI is not equal to AI plus 2, then also swap AI comma AI plus 2. Cool. And now AI is the one that is different. If now AI greater than AI plus 1, we can do that, then T plus plus. And okay, so we have S and T. Our final answer is going to be, if S is positive, initially they are like 0. If S, then answer multiply by equal to S into T, and answer remainder modulo by M. If T, then answer multiply by equal to T into 3, and answer multiply by equal to M. Remainder M. See out answer, and let's see. Hopefully. Wait, shit. Okay, my bad. Sorry. We do not have different test cases. Hmm. Okay, this is correct, but this is wrong. Maybe we are messing something up before changing answer. See out answer. And we will also see S, see out T. Okay, 1 and 6. 1 is okay, 1 is okay, and 6 is not okay because n is 12. n by 3. n by 3 is 4. So we have 4 factorial divided by um, 2 factorial. 2 factorial, that is actually 6. So 6 into 3 into, wait, shit, we are getting the wrong answer here. Hey, fix my code. What do you mean? I have a school project and I am unable to configure my code. Lol. Python. How to run? You can join the Discord and do something there. Can you please guide through your Linux setup? No, this is not Linux. This is Mac OS, and I'm sorry for using Mac OS. Like, yes, that is a bad thing to do, but this is not Linux. And if you do want to use Linux, then you can go with Arch Linux. So you can post your code in Discord and someone might be able to help you. Okay, you can do that. And for if you want to set up Linux, there is a command that comes with the Arch ISO, and that is like amazing command. And you can start with that. Arch install. Just boot up Arch and run this command, and you will enter a terminal user interface TUI, and there you can select everything you want, whatever you want. You can say you want GNOME or you want KDE or whatever you want. You can just select, and this Arch install program, which is I think a Python script, which Arch ISO itself contains, everything will be installed. You don't have to go through anything. GNOME, Genome, anything does not matter. Vim. I'm using Vim. Yep. Welcome. Vim is cool. And 6. But then how did we get 3 into 2? Uh-huh. We did this. 3 into 2 into 4. 6 into 4. No, 3 into 2. Yes, 3 into 2 into 3 into 2. That is 6 square, 36. Shit. So, okay. S equals 1. T equals 1. So what is the problem here? And answer initially was equal to 6. So 3 into 2 into 6, that is 6 square, should be 36, but somehow it is not. Answer was equal to 18, which is, yes, 6 into 3 is 18, and then okay, cool. Now it is correct. Now working as funktioniert. Cool. Okay, we can go with this and we can submit. That is nice. And this might work. I'm also learning C++ and Python, and I started competitive programming like a month ago. I'm 13. Bro's a child. Okay. C++ is a very harmful language for a child, so be very careful when handling C++. Okay. Wrong answer on test 6. I think it is because of how we are handling. Yeah, because n was very big. That is the only possible explanation. And yes, that is the only possible explanation. Everything else is amazing. How we are calculating inverse. Inverse is this. Right? You can check CP handbook. That is creepy pasta somehow. Creepy pasta. CP handbook. number theory, modular inverse, modular exponentiation, modular inverse, and when m is a prime number, Euler's theorem, and that is a general. Yes, when m is a prime number, then modular inverse is x raised to the power m by 2, and that is what we are doing. X raised to the power of m by 2, and then multiply answer and inverse. Yes, n was big, 30,000. Output was this, but the actual answer is this. Yes, that is because of modular inverse. Modular inverse. And we can look at the editorial now. That would be fine. Yeah, 13 is crazy, by the way. Yes, actually crazy. We can look at the editorial. It is fine. It is fine. We do not have to feel bad about looking at the editorial. We are just learning. Let's see. Wait, this is their final formula. And if you notice, wait, this is a bit different than our formula. Well, this part is same. At least we nailed that much. This part. Wait, where is the part? N factorial combination. Yeah. N by 3. Choose N by 6. Wait, shit, we can do that. I think we have n by 3. So the formula that they have written is n by 3 combination with n by 6, and this thing is also equal to n by 3 factorial divided by n by 3 n by 6 factorial into n by 6 factorial. So yes, we nailed this much, but this part is different. I think this is their way of writing the same thing that we are writing. Wait, what is C1? How are they defining C1? Let's ignore the constraints on the number of red and blue vertices for a moment. Okay, we can do that. What is the minimum possible weight? What is the minimum possible weight of a coloring when we are not taking the biggest element? From any triplet, we can have two edges connect two vertices of different colors. Okay, minimum possible would be when all the vertices have the same color, so 0. 0 would be the minimum possible weight. So the maximum, okay, they are asking for the maximum. Maximum would be when we are not choosing the smallest vertex. So the maximum possible weight of a coloring, not necessarily a valid one, is the sum of all the edges weights except for the minimum weight in each triplet. That makes sense. Let's show that it is always possible to choose a valid coloring to achieve this weight. I think it is always possible to choose something. In each triplet, we should make sure that the two maximum edges connect to vertices with different colors. To do this, we can color the vertex incident to both of these edges in one color and the other ones in the other color. Like if the vertex which has, if we were to draw this, that would be much better. So what they are saying is we have edges which have weights x, y, and z. And in this, let's suppose z is the smallest. So z is bad. We do not want z. Z is small. We want x and y. And to get x and y, these nodes that this x edge is connected to and this y edge is connected to this one, and this one should have different colors, and we only have two colors. We have red and we have blue, and these should have different colors. Let's say we color this one edge in any color blue, then this should be some other color, and the only other color is red, so this will be red. Now we get the edge with the weight x, and to get y, this node should have a different color from this one. This is blue, so this should be red, and this is the only possible configuration for something like this, and that is nice. So that is what they are saying. The node on which these two are incident, we color that node in some color, and the opposite remaining nodes in the other color. If this is blue, these two are red, and if this is red, these two are blue. That is what they are saying. 3 lakh, not 30,000. Wait, did I misspoke something? And to do this, we can color. I guess I misspoke the answer for this one. The value of n, right? N is 3 lakh. Yep, 300,000, not 30,000. Nice. And that is big. And all I want to know is how they are calculating the factorial. Add that is something new. Add x plus y, take modulus. Then add modulus, and okay, then that is nice. That is nice. If uh, x plus y modulus mod is like negative, then we add mod and take mod. That is just to make it positive, to make this thing positive. Multiply, make this long, multiply these two numbers and take mod. Okay, and bin power, binary power. So int z equals 1, while y, okay, this is binary exponentiation, and we are not taking mod, we are taking mod here. If y is odd, then multiply z by x, and then multiply x by x. Okay, yes, this was one way for finding powers. Binary power. No, this binary power is a different thing. Binary power, bin power, and inverse. See, inverse is this exact thing. X raised to the power a mod minus 2, and divide x by y is multiply x by inverse of y. That is very nice. We are messing up somewhere. We are messing up somewhere in our functions. Our power function is like amazing. If b is 0, a raised to the power of b, what we want is a raised to the power of b, and the whole thing modulus m. When b is 0, we return 1. Now, if then we say answer is equal to a raised to the power of b divided by 2, right? With the modulus m. And then we multiply answer by itself because we did b divided by 2, and then we do this. If b is odd, then we multiply answer by 1 and take remainder by m and return answer. And here in this part, we do not have to take modulus with m because when we return answer, we are taking the modulus first and only then we are returning answer. So that is fine. I think problem could be with the factorial function. Factorial function, yes. Factorial function, it starts with 1. Okay. and starts from going with 2, I equals less than n, I plus plus, multiply answer by I and take modulus m, and at the end return answer. That is the perfect definition for a factorial. And this also will not become very big, because this will not become very big because we have a reason for it. Here, wait, this might, okay, here n has at max 6 digits, 5 zeros and 1 integer digit, so 6 digits in total. And our number might become as big as this number, which has 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. And when we multiply a 6-digit number by a 9-digit number, at max we will have 15 digits. And 15 digits can fit inside a long. So that should not be a problem here when we are multiplying answer by I, even if I becomes very big and answer becomes very big as these two can be, still we will not get a overflow and this should work. So this also is correct. Yeah, this is correct. This is correct. So we are messing up somewhere else. I think this maybe. Yeah, I think this part is a bit more complicated, a bit over-engineered than it is supposed to be. This can be much better than this. Okay, here we take in A, we fill the A array, and then we are iterating through every triplet like this. And yeah, we are iterating. We don't even have to do this because we are always jumping by a gap of 3. So yeah, at some point we will get up to n and we will exit at that point. So if all of these, all the elements in this triplet are equal to each other, then increase s by 1. But if only two of them are equal to each other, which we will know if this thing is true, then we have to see if the one that is not same, since here, let's say we have three numbers x in a triplet x, y, and z, and we know that two of them are equal to each other and one is not equal to each other. We want to see that the one that is different is bigger than the ones that are same. And this is what I was doing to do that. But I think this is kind of over engineered. Here, what I'm trying to do is I'm seeing if at the end, at this point, when we go into this if condition, I want AI to be the one that is different. And this if statement makes sure that AI is the one that is different. So here, if we have AI plus 1 not equal to AI plus 2, that means these two numbers, the next numbers x and y, are not equal to each other. So x is equal to something, but we do not want that. We, after seeing this, we see if AI is equal to the next number, is not equal to the next number, then we swap AI with the next number. And if AI is not equal to the next number, then we swap AI with that number, and then we do this. Well, this actually doesn't seem that much over-engineered. This does seem fine. And then answer is factorial n by 3 with modulus m, and denominator is factorial n by 3 modulus m. Okay, this might actually be a bit too much because denominator can become as big as this number minus 1. And when we have this number, minus 1 raised to the power of 2. We have this number with like 17 digits. That might be a bit too much. Let's make this unsigned to just get a little bit space. Yeah, that might be the one causing the problem. Unsigned. And is that like correct? LSP start, clang, D. Okay, that is kind of wrong. Long, unsigned. That is right. Okay, then multiply denominator by itself. Yes. And do we know that denominator is okay? Yes, denominator is okay. It is a modulus of m, so that is cool. And then long inverse, we find the inverse for denominator, which already is very big. That is fine. That is fine. That is fine. That is fine. And multiply the answer by the inverse and take modulus with m. That is nice. And then if s is there, then multiply answer by s into 3. And if m is there, yeah, then take modulus with m. And if t is there, multiply by t into 2, twice the number of t. This does work here. And the only change that we have made, like literally the only change we have made is this. We have made this thing unsigned. Let's see if this works. That would be nice if this works. Hello, just finished two med questions here. What is med? And you are laughing. That is cool. What's up? Yo, wrong answer on test 6. Ah, shit. It's exact same answer as before. So we are messing up with how we are handling inverse and things. Let's read the editorial. We are clear about the theory, but the implementation part is messed up. Let's show that it is always possible to choose a valid coloring configuration to achieve this weight. Yes, it is always possible. In each triplet, we should make sure that two maximum edges connect vertices with different colors. To do this, we can color the vertices incident to both of these edges in one color and the two other vertices will be painted in other color. And the two other vertices will be painted in other color, yes. So if for each triple of vertices, there will be either one red vertex and two blue ones, or two red ones and one blue one. Let's suppose the first n by 6 triplets have one, because there are in total n by 3 triplets. So first half triplets have one red vertex and two blue vertices, and the remaining half n by 6 triplets have one blue vertex and two red vertices. That way we obtain a valid configuration with maximum possible weight. Okay, now let's try to find out how do we calculate the number of valid coloring with maximum possible weight. Each triplet of vertices will be either red, two red, one blue, or blue and the other way around. Since exactly half of the vertices should be red, then exactly half of the triplets should be red. So the number of ways to choose a coloring of all vertices is this much. Yes, that is true. That is true. After choosing the coloring of each triplet, let's choose how we actually color them. The triplets are independent, so for each triplet, we can introduce the coefficient Ci, where C is the number of configurations for each triplet individually so that its weight is maximized and the triple has some specific type, either red or blue, doesn't matter since these are symmetric. Yes, choosing the vertex which will be different from its neighbors is equivalent to choosing the edge which will not be included in the weight for coloring. Yes, choosing the minimum edge. This is the edge which is not incident to the chosen vertex. So Ci is equal to the number of ways to choose the vertex in the ith triplet so that the triplet is maximized. That is the weight of the edge not incident to the chosen vertex should be minimized. Yeah, yeah, that is S is the number of triplets which can have three different internal configurations, and T is the number of triplets which have two different internal configurations. That is okay. I will look at it later after the stream at some point. Lead code medium. That is nice. That is nice. This is not nice though. How long has it been? It has been 1 hour and 21 minutes and not even a single question solved. That is not very good. Stopwatch. We will do this next question. Hmm. Okay. We'll do this next question in about 40 minutes at least. Yeah, at max in 40 minutes. And if we are unable to do this in 40 minutes, we will look at the editorial because I have to do at least 4 questions in the stream or at least attempt to do 4 questions. We will not count the one that we just did because it was a question from yesterday. So today we have equal frequencies, then flexible string, then interesting sequence, then sending a request, sending a sequence over the network. First one, equal frequencies. Let's go. Okay, cool. Let's call a string balanced if all the characters that are present in it appear the same number of times. Okay, this is not, this is balanced. This is also balanced. This is balanced. This is not so balanced. This is not balanced. Code force is not balanced. You are given a string S of length n consisting of lowercase English letters. Find a balanced string S of the same length n consisting of in lowercase English letters that is different from the string S in as few positions as possible. In other words, the number of indices I such that Si is not equal to 2 should be as small as possible. Okay, we have to convert. Okay, so we have to convert S into T. So minimum number of changes and S has some okay, n, and let's say we have X number of characters that we are using, and we need to divide n into X as efficiently as possible. That would be just the average. And we could also, we need to come up with a frequency f. So right now, let's say we have X characters initially. Let's say A is appearing some number of times, B is appearing some number of times, then H is appearing some number of times. And let's say this one appears F1 number of times, F2, and this is appearing F3 number of times. we need to change this to f, to a frequency f. Let's initially suppose total we have n things, and let's say n is divisible by 3 initially. And when n is divisible by 3, then there is only one possibility. Wait, wait. Here we have three appearances, A, B, and H. The average should be about this much. F. F is the average, but we have A appearing some number of times, F1. We have B appearing some number of times, F2. And we have H appearing some number of times. And what do we have to return? We have to return that target other string T. Here, the cost would be this and this. Hmm. The cost would be this plus this, and let's say H is already here at the correct frequency. Let's say we this feels like dynamic programming somehow. So when we have something like code forces, say code forces, here we have a bunch of characters. We have E. E is appearing 2 times. Before E, we have C. C is appearing 2 times, then E. D is appearing before E. D is appearing only 1 time. Then we have E, A, B, C, D, E, F is appearing 1. G, H, I, J, K, L, M, N, O, P, Q, R, once, S, once, and is that it? Nope, we also have O. O is appearing 2 times. 10 characters, and here we have 10 characters in total. So that is cool. Yo, I don't know. Okay. Uh, so here clearly, here we have 1, 2, 3, 4, 5, 6, 7 characters, and we need to, and n equals 10. N equals 10. So we can have 2 characters or 5 characters, or 1 character that is appearing 10 times, or 10 characters, and maximum quota is exceeded. Shit. Yes. So which one would be better? When we are going with 5 characters, that is in total our final string will have only 5 distinct characters. In that case, every character must appear 2 number of times. Okay, in that case, every character must appear 2 number of times. This is not dynamic programming. This is simple maths, simple thing. If every character is appearing 2 number of times, here we will ask ourselves which number, which character to change and which to not change. Yeah, changing this is not good, right? Because like the cost for changing, keeping this, if we keep this character, then it is already at this target frequency. This one is also at the target frequency. This is also at the target frequency. And to change this, to keep this, okay, let's count how much cost would increase if we want to keep all of these characters. For keeping this, cost would be 0. For keeping this, cost would be 1. For 0, 1, 1, 1, 0. Because we want these characters to appear one time. And yes, we want these characters to appear one time, two times in total. And this one is already appearing two times. This one is appearing one times. So we have to increase, like add D at some point and one time. And yeah, same for all of these. And among these, let's say after this, we will sort this. And we will have something like 0, 0, 0, 1, 1, 1, 1. In total, we have 3, 3, 7 characters. Yes. And from this, we want only 5 characters. So we take the 5 characters with the smallest cost, and our total cost is just 2. And that is good enough. And we will remove these characters. And that is nice. That is very, very nice. And yes, that is very, very nice. That is very nice. Yes, we can do this. We can do this. And let's say there are for any n, there are log n factors for any number in average. And when we are at a current factor of n, it is going to take us O of n time to find the best one. But also we are sorting the thing, but we are only sorting 26 characters, right? So that is not a lot. Yeah, we got this. We got this. We can do this. That is fine. Hello. Okay, you can make your code forces theme dark. There is a like a specific extension for that, just for making code force. I think this. Oh, yeah, no, this is not the one. Dark mode. Wait, shit, I removed that extension. Yeah, you can also use this dark reader extension for dark mode, but yeah, I like it with white mode, at least on code forces. E and LSP stop and n, and then we take in the string, yes, not G but S, and then we will count the frequency of each characters, vector, integer, and pick frequency of size 26 because we have 26 characters and so everything is 0, and cool. For n or char C and S frequency of C minus A plus plus. Increase the frequency, and we will iterate through all the we will iterate through all the factors of n beginning from 1. Int final, wait, small names. We have to choose small names. Let's say int count. Count will give us the number with the minimum cost, like this number here. I think 5 has the minimum cost, and yeah, we will get the number which has the minimum cost. I begins from 1, and I shit. To go through all the factors of n, it only takes root n time, which is like even better. And internally, for each root n thing, we will be doing something for n time log big O of n. So the total time complexity would be n root n. That is acceptable because n is not very big. I less than equal to square root of n I plus plus. If no remainder when n is divided by I, if we get that is I is a factor of n, what do we do? I is a factor of n, which means we are at some place, one of these numbers, which is a factor, and we will see if that is, then what would be the frequency that is required. So the frequency that is required, f would be n by, since there are in total n characters and we want to keep I of them, so each I should have a frequency of n by I, right? Each character should have a frequency of n by I. And now we take the cost. We already have a frequency. Let's create a vector of pair of integers where the second number is a char and the first number is going to be the cost. And when we sort this vector based on the cost, yeah, we will sort them according to the first integer. So that is nice. Cost, we will have 26 of these char, and that is very nice. That is very nice. Let's also fill this. I less than 26, I plus plus, and cost I dot second equals I plus h. That is our initialization. And now we will go through all of these. I equals 0, I less than 26, I plus plus. Cost for the ith character, which, and yes, this current character in the vector is going to be cost I dot second, that is the character. And what is going to be the cost for this character? Cost I first is going to be required frequency, the absolute different of the required frequency, which is f, and the current frequency. Current frequency is frequency of c. That is the cost. Yeah, that is nice. And then we can sort cost dot chicken and cost dot end, and we will take this is okay, this is okay, this is okay, even if this is very much okay. Yeah, okay, cool. We can then sort this, because we will also be considering the elements, the characters which are not in the string at all. Like in this case, we are not using uh, b, and the cost for b would be 2, because b is not appearing not even once, and we want the total frequency to be equal to 2. So we will increase b by 2 times. What's the optimal frequency we need to convert each element into? Okay, because n, in the end, let's say x is the number of distinct characters that we will have, right? And x must be divisible by n, because x is like the number of distinct characters. Let's say f is the final frequency. We have to have x into f equal to n, and I am iterating through x, and f is just n divided by x in that case. Yeah, this, and then we are finding the cost and finding the like best optimal cost. I think that makes sense. Okay, and CNT count. Okay, and let's say that the initial cost int CST is very big, int max. Now, what would be the cost for this particular thing? In C, cost, current cost is, okay, we can use a very nice function now. accumulate of, I think we can also pass in a custom function because we cannot blindly add cost. This has been cost is a pair. I, yeah, we do not have a function which defines how two pairs should be added to each other. We can define it here if you want. Let's say here int reference. Nah, that is not very good. Yeah, we should like do this by hand, I think. Int c cost initially is 0 and for int not I, we are not using this. Yes, we are not using this. And j equals 0 and j less than I because we only want I numbers. I distinct numbers. So I cannot never ever be greater than 26. Shit. Shit. Yes, because I is representing the number of distinct characters and we do not have more than 26 characters. So I cannot be greater than 26. That makes sense. J less than I because I is the current count of characters that we need. And J plus plus. Now C cost plus equals cost I dot first. That is the cost. Now if C cost is smaller than the current global cost, then cost equals C current cost and also C and T equals I. That is very nice. Very nice. C out, C and T. Okay, so for hello, in the final answer for hello, we have 5 distinct characters. We should see 5 or maybe a error. Okay, we messed up. You wrote begin in the sort. Yeah, you have to use lambda for the accumulate function, but I think it would be more complicated because yes, lambda. Okay, let's see. Wait, before using accumulation, why are we getting this out of bounds error? I is less than 26 when we are iterating here. That is good. This is also good because everything in C is a character. Pair 26 integer char character. This is nice. I is smaller than this. And also, yes. There is also like the opposite thing. We will have to do this again if I is not equal to n divided by I and paste. Do all of this again with like OI as in like other I. And in this whole thing, we will change substitute I well by OI. Okay, we can use a feature by Vim, this C flag, which will ask wherever we are doing the substitution, do we want to confirm the substitution? Currently we are here and we do not want to do substitution, so no. Yes, yes, no, yes. Okay, okay, that does make sense. That does make sense. I see the mistake. I let's say this is x and cost of I, not cost. Well, this wouldn't be wrong because I would be inside this scope and is not changing anything outside the scope, so that is fine. That should have been fine. IO and this has to change with x, 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 and wherever do we have I? Here we have IO. This has to become IO. This also has to become IO, and this also has to become IO. IO n divided by IO. That makes a lot of sense. And IO equals n by I. I is not, IO was not declared in this scope. Where am I using IO? Line 38. Out of bounds. There is an error. Out of bounds. Sort cost dot begin. That is very nice. Cost, current cost is 0 IO first. Shit, this has to be J. Okay, shit, for this is going till 26. This also has to be J. Okay, that was the mistake. That was the mistake. That was the mistake. That was the mistake. I think. Okay, no. There is something else. There is something else. Are we going using I inside? Count is I. J less than I. That is good. X is always smaller than 26. High. Do we see the high? We do not see the high. So the mistake is above this point. Do we see the high? We do not. Do we see the high? We do see the high. So the mistake is in this jar C frequency has 26 and minus E. Why is that wrong? C out C minus A. Plus and minus 44 is kind of crazy. What is C? C is 5. True. Because we have to take in N. So that does make some sense. Now we should not get at least, yeah, we shouldn't be getting out of bounds now. Pi see, we do see the high, so we are getting inside here. And when are we getting the error? Okay, we are getting error before this point. Yes, we do go here, but we don't go here. Yes, so error is in this point. That is binary search, searching for the error in the binary search manner. Okay, X starts from 26 and cost has a size of 26, so that is fine. And cost X frequency C, we are okay. Yes. Sorry, shit. Yes, that should be it. We cannot just access frequency for C. We have to do -A. We have to do the same thing here, -A. And we can, I think, remove the high. Okay, wrong answer is much better. So for here, it is best to have 5 characters. For the second one, code forces, it is best to have 5 characters. For this one, it is best to have, I think, 1 character. And yes, cool. And for this one, it is best to have 3 characters. That is very, very cool. Cool. That is crazy. And how do we return? What do we have to output? For each test case, print the smallest number of positions where string s and differ. Okay, the cost. Cost. We have to output the cost. First, output the cost, and then the string t initially is just like s, and then we will iterate for int I equals s, I equals 0, I less than n, I plus plus. Now what do we do now? Now we do this thing again, count the frequency of each characters and find the one which we are going to go with now. Since we know that we are going to have C and T number of elements, so their frequency should be F. And now here we are calculating cost for when we want to consider each element. Yeah, and here we are changing this, and okay. Okay. Yes. Cool. And then we will have another vector of integers, uh, key size 26. We already know their frequencies, and we also know the target frequencies. We just have to know which ones we are going to keep. And yes, which ones we are going to keep. Yes, that is all we know. We can use a set of characters called keep, and for int I equals 0, I less than cnt, because we are going to have cnt number of things, and keep dot insert from cost x dot second. This is one of the characters, cost I dot second. This is one of the characters that we are going to keep. And now And we also know its target frequency, which is f. F is going to be the target frequency. And we also have their current frequency in FREQ. And I has the frequency for the ith character. Now, if the current character is one of the characters that we want to keep, that would be the keep dot count, and the current character is si. Current character is si, and if we want to keep this character, then we will see what is the frequency and what is the target frequency. Target frequency is if the target frequency is greater than the current frequency. Current frequency for this si character is this. Then we want to increase its count, and that is fine. We cannot do this right now. But if the target frequency is smaller than the current frequency of this character, then we remove this character. And which character do we put here? Shit, we have to put some other character here, which we do not know about. Some other character which has a frequency that is lower. So I think we should have two vectors, two sets here, in and decrease. And for the current character, if target frequency is greater than the current frequency for this ith cos current frequency, C is cos I dot second, and the current frequency is C minus A. Then we need to increase the frequency of this character, and we can say inc dot insert C. Else, well, if the frequency is smaller, else if f is smaller than rec, then C minus A. C minus A is the frequency, current frequency, and this will be, we want to decrease dot insert C. And if the current frequency and the target frequency is same, then we do not do anything. Hello. I recently switched to NUM and I'm still getting the hang of the motions. Any tip or advice would really appreciate. Yes, there is NHYVHYROO, this guy, and he has a playlist on understanding NUM, 10 videos, and this is one of the best things you can watch if you want to understand NUM. And why are random videos coming up when I'm searching for NUM? Yeah, you can watch this playlist and this is going to help you immensely. Yeah, that is one thing I can recommend. Okay, and back to this question. No doubt, what if there is a string with frequency of 2 and rest all correct? What? What if there is a string with frequency of a equal to 2 and rest of the characters from b to z have a frequency equal to 1? Then how will you solve it? So n would be equal to 27, right? n in that case would be equal to 27, and in total at the end we could have one distinct characters, three distinct characters, then the next factor is 9 distinct characters, and 27 distinct characters. But we cannot have 27 distinct characters, so cut that. You can have 3 characters with frequencies 9, or 9 characters with frequencies 3, or 1 character with a frequency 27 times. That is obviously bad. So answer would be 9 characters with a frequency of 3. And that would be, you just keep 2 of those A's which you have and change one of the other characters into a and choose other 8 characters other than A and increase their count to 3. That would be the answer. And the total cost would be, since you are changing one of these A's out of 27, you are not changing these two A's and those other 8 occurrences of characters. So, and you are changing 17 characters, so cost would be 17. And the new string would be something like this, where you have 3 things of this, yeah. And your target is, if your initial string looks like this, A, B, C, D, E, F, then your answer could be A, B, and then C, C, let's say A, B, C, D, E, F, G. We have 2, 3, 4, 5, 6, 7, 8. Already 8 distinct characters. And after this, we have one A to increase the frequency of A. Now A is appearing 3 times, then 2 Bs, then CC, then DD, and so on till at the end GG, and that would be the answer, I think. Yeah, like the cost will be minimum when we do frequency equal. How can you have frequency of equal to 1? Because in total you have 27 characters. 20 n equals 27. You do not have 27 characters in the English alphabet. But you cannot change the second character of Z into any other character. You cannot have a frequency equal to 1 because we do not have enough characters to fill the whole string. Appreciate the motions are giving me a hard time after moving to new M. I'm good with the setup and LSP. Okay, you already know about LSPs. That is good. LSPs, tree setters, but the motion still feels chunky. Any tips? Now, just spend more time. And there is also this plugin by Primeagen, Vim be good. So maybe this might help you a bit. You can use this to practice the motions. This plugin, Vim be good. It is good. And now let's write down this increase or decrease. Now we will go through each of the characters, and if the current character is something whose frequency we need to increase. Now the final task is, right, got it? Now the final task is to just create the target string. We already know what things we need in the final answer. Just creating the target string. If I think we will have to do 2 passes. In first pass, we will clear this increase. Yeah. In the first pass, we will clear this increase. No, shit. Okay, if the current character SI is the current character is an increase. If int dot count SI, then we need to increase this current character's thing, and like, okay, we cannot do anything with that. We only want to change if the current character is something that we whose frequency we want to decrease. So if dick dot dick, and if decrease dot count SI, if the current character is something that we want to decrease, or the current character is not in the final vector. How do we see that the current character is not in the final vector? by creating another set. Uh, and whenever we see this thing, we will do t dot insert c, or we have keep dot count for this current character si not like equal to 0. Then we want to remove this character, and now we want to decide which new character to put in t, right? We can see that from increase in c equals inc dot begin, take the first character from there, and we want to increase this characters count, so we will do t I equals c. And also, since we have now changed frequencies, let's update the frequency of si. We have decreased that, and frequency of c, wait, minus a, and frequency of c is increased. Now, if frequency of c equals the target frequency, then we can remove this from the increasing vector, and that would be inc dot erase inc dot erase c. Good. Yep. And since we have changed the frequency of si, we have to only see if this was one of the elements which we want to decrease, and if it is, then do we want to update the decrease? No, I don't think we have to update. No, this is fine. This is fine. You can just output the answer now. And hopefully, Hiabo. That is messed up. What is Hiabo? Code Apple. That is nice. And code Ford. So, okay, we are messing up. And why do we even have a B here? Like B does not make sense. Yep, we are messing up somewhere. Yes, we have to update the decrease. Yes, if dic dot decrease dot count si, if this is one of the characters which you want to decrease, and also we have and the current frequency of this thing, frequency for si minus a equals the target frequency f. Then we do not want to decrease this anymore, so decrease dot raise si. This might just not work now. Okay, I will go to the washroom and I'll be right back in a minute. I'll be right back. I am right back and let's do this. Okay. What is the अपने college GitHub controversy? I don't know. GitHub controversy? Why would they have a controversy? I think it is that they have videos अपने college on how to contribute on GitHub, and then people watch those videos and they flood the PRs of those repositories and they just make random bad contributions to those repositories, and the moderators get overwhelmed from these random bad newbie um, pull requests, and that is bad. I think that might be the controversy. Cool. And this thing is not working. Two. Shit, this two is not good. H. Hello, H-E-L. That makes sense. Mother 2 is not correct. H has a cost of 1. 0. H has a cost of 0. E has a cost of 0. O has a cost of 0. Okay. E, this does make sense. This does make sense. This does make sense. Code O F. Cost is to okay, code force is actually correct. This one is actually correct. C is appearing 2 times. O is appearing 2 times. D is appearing 2 times. E is appearing 2 times. F is also appearing 2 times. So that is good. And O is, yeah. And that is good. But this is wrong. This is wrong. This is wrong. This is wrong. That does make sense because L has a cost of 1 and B also has a cost of 1. Yes, that is wrong. They have each L has cost of 1 because we want to decrease it to and replace it by some element. Hmm. So cost, we cannot just see cost is going to be that much. I think we have to change our cost function. This the way that we are calculating cost. Here we are saying cost equals absolute difference of the target frequency minus the current frequency. But 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 we also have to consider, yeah, other things. If okay, if the current frequency of our element is higher than the target frequency, then the cost is going to be that difference. I think then the cost should be 0. We can treat not as 0, since we do know that we will have to remove all of these elements, so the cost cannot be 0. But but Let's say that the cost is 0. 0 is not nice. 0 is nice. 0 might work, 0 might not work. What are you using the emotion for getting inside parentheses? I don't like getting inside. F, look at this. F and then the parentheses, right? Or you can use F with anything. If I am here at the start or anywhere in the line, if I want to search, I think you might know this line. Anything to the right of your current cursor position, you do F, X, you are at the X, and then you can do semicolon to repeat that search. I'm just pressing one key, semicolon. My other hand is here, semicolon, semicolon. So I will like make the search again in the same direction. But if I want to do the search again in the opposite direction, then comma, comma, comma. That is nice. And one more thing, if I want to select everything in these parentheses, then we can do Y, look here, Y, yank, I, inside, and then the parentheses. Shit. Y, I, this. Y, I, Y, I. Shit, yes, Y is just yanking, so yes, I am yanking. If I want to select, press V, V, I, parentheses. Everything inside the parentheses is selected. But if I want to select the parentheses themselves, then V, A, around parentheses. They are also selected now. That is nice. Yeah, that is kind of nice. How many questions one should solve to conquer a specific rating on CF? I don't know for everyone, but I am going with at least 50, at least 50 questions. And I haven't solved 50 questions in all the ratings. So yeah, I will have to solve more questions. And this is bad. It is already about 1 hour and I haven't done a single question. Bad. Frequency of C. If, yeah, I think because you will always have that number, right? Yes. Okay. So if frequency of C minus AI, the current character, is greater than the target frequency, then cost x dot first equals 0, else cost x dot or shit equals minimum maximum of 0 or target frequency minus current frequency of C minus AI. I think everything else should just fall in place as we have done them. Here also we have to do the absolute minimum function. No, maximum 0. Okay. F minus AI maximum. Yes. Yeah. And then sort this thing. Yes, we should get the correct answer for hello. Yes, we do get the correct answer for hello. That is nice. Let's submit. This should work. This should work. Can we do like if we are using frequency, let's say 3, then cost will be number of characters. Don't have frequency 3 divided by frequency. Runtime error. Okay, that is messed up. That is messed up. Can we do like if we have a frequency, let's say 3. Okay, we want every character to appear 3 times, then cost will be the number of characters. Don't have a frequency 3 divided by frequency. The number of characters which do not have a frequency of 3 and their frequency is smaller than 3 or greater than 3. The cost, no, but it will depend on how much different the frequency. Okay, you are talking about the total cost, or we have two costs here. One is the total cost, and the other is cost for having a particular element in the vector. There are two costs, and we are messing up somewhere. Why are these like in different colors? Okay, we are messing up quite a bit. Runtime error is crazy. Out of bounds. J is too much. J is n divided. This is actually just if no, we don't have to do this. We don't have to do this because we are going till 26. Shit, that was actually stupid. Shit. We are getting the correct answer. That is nice. Yo, thank you. Bro's a hacker. Bro's a hacker. Yo, okay, cool. But 1 hour is bad. Okay. 1 hour is bad. And we will now do the next question. Whether it's smaller or bigger, we want to change all into 3. Yes. Yes. And there are two individual costs. Uh, yeah, this is accepted. That is nice. There are two costs. One is the cost for each element. Let's say f is our target frequency, and for each element, if we say we want to keep a, then there is going to be some cost. If a is appearing less number of times than f, then the cost is going to be target frequency minus frequency of a, and same for everything. But let's say c is appearing higher number, like more number of times than f, then the cost is going to be 0. Why? Because all the other occurrences of C, we have C appearing in our string some number of times, right? And all of these occurrences extra occurrences. Let's say our frequency is 3, target frequency is 3. So we want to remove one of these occurrences of C's. And this cost is not actually cost. We will remove this when we are increasing frequency of something else. So if we keep this 0, when we increase frequency of some other element, this C will be removed automatically, right? So that is nice. So we can, instead of saying that what is the cost for taking this character to a frequency of exactly f, we can say what is the cost for taking this character to a frequency of f or greater than f. C is already greater than f, so cost is 0. A is smaller than f, so the cost is f minus fa. And then we will say, we'll choose all the elements. And also one more thing, if C has a higher frequency than the target frequency, then our final string will have C, because if we want to replace all of the occurrences of C, which is greater than F, what is the point? No, that is like bad. You can instead just remove the extra parts of C and not these F times that C is occurring naturally. You forgot who I am. Shit, sorry. You are right. For higher frequency of characters, frequency we want. Yes. Stole your dot files. Don't mind. No, that is fine. That is fine. My new files. And sorry, I don't. I kind of remember. My bad. That okay. That is nice. We have done this question. Let's guess, or yeah, guess the tags. Tags are going to be constructive algorithm and strings and sorting. Constructive algorithm, sorting and string. Check. Okay. Implementation. Yeah. Greedy and brute force. Yes. Greedy is also something, and brute force. Cool. That is nice. Let's read the editorial quickly and we will move on to the next question. Question number C. Equal frequencies. Instead of finding T that differs from S in as few as places, let's formulate it as finding T that matches S in as many positions as possible, which is obviously the same thing. Yes. First of all, let's fix K, the number of distinct characters string T will have, since the string must consist of lowercase Latin English characters. Yes, K is from 1 to 26, which is exactly what we do, from 1 to 26. And since the string must be balanced, we have n mod k equals 0. Yes, and k is a multiple of n. For each k that satisfies these conditions, we will construct a balanced string that matches s in as many places, as many positions as possible. In the end, out of all the strings we will have constructed, we will print the one with the maximum number of matches. Should we are going to construct a lot of strings. From now on, we assume k is fixed. Okay, suppose we choose some character C to be present in the string T. We need to choose exactly n by k positions in T to put C. Let frequency C be the number of occurrences of C in S. Then in how many positions can we make S and T match using character C in frequency C places? The answer is minimum of the target frequency or the current frequency. That makes sense. Positions. Now, since you want to minimize the total number of occurrences, we should choose k characters with the largest values of these. This is also equivalent to choosing k characters with the largest values of frequency C. That is also true. That is also true. How to construct the desired string for each chosen character? Pick any min frequency C of its occurrences in S and put C in the corresponding positions in T. Then if frequency is smaller, save information about this unused C characters. Otherwise, if frequency is higher, then save information or the empty positions in T. In the end, match the unused characters with the empty positions arbitrarily. That is cool. That's cool. Yeah, that is different implementation for the same thing. And we can move on, hopefully, to the next question. This one took 1 hour. Wait. Oh, triangle coloring. We did this one. No. We did this one right now. 1 hour is a lot of time. Refresh. This will increase by 2. That is nice. And now flexible string. Wait, should yes, this one we didn't do triangle coloring because of some modulus operation. I think it is wrong. Check your teams. Oh, shit. Okay. Cool. Yes, you got a rating of I guess 71, positive delta of 71 in the last contest, and that is very nice. You were able to solve the third question. Yeah, shit, now I remember. You were able to solve the third question faster than me, which is very good for you, but I do not like that. I have to grow very strong. This is competition. I will reach candidate master before you. And we also have Anshu Singh here. See, we both stalk each other. Yes, we do stalk each other. Friends, rating changes. Yes, yes. You had a rank higher than me. That is, that is nice for you. But yes, I will beat you. I will beat you. I will become candidate master before you. You got a positive delta of 72. That is a lot. I'll become CM. Lol. Yes. And Anshul is also in the race. Let's see who becomes CM before. Uh, of course, you guys are in the competition, so you have to stalk. Yes, we do have to stalk. See what the other team is doing. Wait, shit. If we are, yes, we are serious about reaching CM, but about the stalking part, if we are serious about the stalking part, then I would have to hide my strategies, right? There is a Sun Tzu quote about this. Uh, the quote is, "Do not tell all your strategies in a YouTube video." So yes, Sun Tzu said that. We, but yeah, my strategy is to do at least 10 questions every day. Let's see who becomes CM first. Flexible string. We have done just one question today. That is much less than 10. You have a string A and a string B. Both of the strings have length n. There are at most 10 different characters in A. In A, you also have a set Q initially. The set Q is empty. You can apply the following operations in the string A as any number of times. Choose an index and a lowercase character C, add AI to set Q, and then replace AI with C. For example, in this, we can do the following operations. X equals 3, A, A3 is E. We replace that with X, and our set will have E, and then we replace 6 with S, and yes, this becomes S, and we have this. And at most, there are 10 different characters, 10 distinct characters at most. You can apply any number of operations on A, but in the end, the set Q must contain at most k different characters. Q only contains characters from the string A, but we can increase them by removing one character again and again. Under this constraint, you have to minimize the number of integer pairs, this such that ALR equals BLR. Minimize the number of integer pairs. Here, SLR means substring from L to R inclusive. Okay, and we have no information about the string B other than its length. And we know there are, why would this be a, oh, you are hiding our code during contest, that is enough, I guess. During contest, we are hiding the code, but after the contest, you can read the code. A has at most 10 different characters. Shit. This seems like maxed out difference. 11 and the pairs, you have to minimize the number of integer pairs. Maximize the number of pairs. Okay, we have to make these equal. Here the answer could have been very big. Here we can make these equal to each other directly, and k is 3 here. That is a constraint. K is 3. Here we can change this to d, and the answer would be 3. Wait, L and R can be equal to, so answer would be 3 into 3, 9 or 6. Shit, 6 is the answer. L can have 3 possible positions, and R can have all the positions to the right. So 3 into 2, 6. That is correct. And here we can only change one character. We can change occurrences of one character. That would be B. And answer would be 4 into 3, 12 or 6. Here we cannot change anything. Here we can change this P to be equal to X. And then the answer would be 4 into 3, 6 for the fourth one. But it is 4 into 3, 12. Answer should be 12 for this one. But it is not 12. We change this. Answer should be 6. It is 6. Here we cannot change anything. And we have one substring with this. So answer is 2. 3. Answer is 3. Shit. This answer is 3 here. We can choose. The only constraint is that R is to the right of L. Okay, size of the substring. When L initially, when we have a substring of, let's say, size X, and initially L has X total positions where it could go. And when L has chosen some position, then R can only choose positions starting from that point to the right. And how many would they be? When L is here, X has one configuration would be L is at index 0, R is also at index 0. When L is at index 0, R has X positions possible from 0 to X minus 1. When so answer should be if X is the length, X into X minus X plus 1 by 2. And in this case, 4 into 4 minus 1, 3 divided by 2, that is 6. So 6 is correct. Yeah, 6 is correct. That makes sense. Look how you get approach for CF questions. You just solve more questions. I think you will develop a subconscious mentality for approaching questions. And also there is an article on code forces in the catalog section. Catalog, go there. There is how to come up with solutions and this one article, how to read problem statements. These two are pretty good. You can read them. Q is how many numbers can we change from A? But also we have to see what is the frequency of numbers in B, because we have no constraint in B. B can have any frequency of numbers, any frequency of integers. So there are a few variables. So there are a few variables that we have. Uh, we have A, we have a string A, we have a string B, and we have size K, the maximum number of, and what is K? K is just how many characters from A, how many distinct characters from A can we change, right? And let's say CA is the number of distinct characters in A, and CB is the number of distinct characters in B, and K is how many characters from the CA can we change. And there would be some cases when K is greater than CA or equal to CA, then we can change all of these characters in A. There is no problem. But how many characters do we have in CB? From CB, this is shit. From CB, we just want to see the frequency of characters of these CB characters. We also have the answer also depends on what are their neighbors, because we want the substrings to match with each other instead of having like if A is like this, some string A and some string B, and we have let's say a choice of making these two characters equal to each other and this one also equal to each other. This is one choice, and here the number of pairs, the answer would be 2, because this is same, this is same, this is same, this is same, and the more ways that we can choose L and R is one way here when L and R are both equal to this, and another way when L and R both are equal to this. And then there is the choice A, B, there is a choice in which we are getting two characters. We can make two characters equal to each other, but they are side by side. So let's say some character C1, C2, and here also C1, C1, C2. Here, the number of ways that we can choose the pairs would be 3. So this is much preferred than the other one. And it's crazy. Do you give recent contests? Yes. There was a contest day before yesterday on 4th of October. Wait, no, shit, it was on 3rd of October. And today is also a contest from 10 o'clock. And the next one is tomorrow. Okay, we have all of this. And yes, the time limit is 40 minutes. If we are unable to come up with a solution, then we will take 40 minutes. Then we will read the editorial after 40 minutes. And we have only done one question today. That is not good. At most 10. There are at most. So CA can smaller than equal to 10. But the thing is, we do not know the frequency of characters. In B, we do not know anything about B. You have strings A and a string B. Both the strings have n length. There are at most 10 different characters. In A, you also have a set Q, and we have no information about B. Nope. The last line contains a string B of length n. We have no information about B. And we don't even need to know which characters we are changing. We just need to know how big those subsegments which are equal are, e- are equal. So like, yeah, we do know something about B, that CB is less than equal to 26 because we do not have more than 26 characters. And now among these 26 characters, we have to choose. Wait, we can change at most k number of characters in A, and there already are CA number of characters in A, and there are CB number of characters in B. Uh, uh, we so one option. w- One option. So CA is the base number of characters that we have, and we have a wiggle room in which we can change, and the distance is k. We can remove k characters from CA, or we can add. Actually, k is the count of how many characters we can remove. If A shit. If k equals 1 and a is a, yeah, this is our a string, just a, and our b string is anything, any permutation of the 26 English alphabet characters, then our answer would be n into n plus 1 by 2. We can change completely this a into b because we are only changing this a. That is nice. That is nice. And at max, we have 10 distinct characters in A. And from these distinct characters, we can remove at max K characters. So we can choose. We can actually see. Okay, we can choose. Okay, yes, shit. Okay. Um, since we can remove at max K number of characters, let's iterate from 0 till K, and internally in A, from the 10 characters that we have, we will choose one by one. Let's say, yeah, let's say this number, which is iterating, is I. We are going to change I number of characters from A. And when I equals, and for these I characters, we have at max 10 possible choices. And what is the maximum value for K? We will iterate from 0 to 10, or 0 or 10, or minimum K, minimum of these two numbers. When K is greater than 10, then the answer is when K is greater than or equal to the number of distinct characters. When K is greater than or equal to CA, then the answer is like we can change A completely into B, and that is nice. That is nice. We can change A completely into B, and that is nice. But if K is smaller than the number of characters in A, then we will run a loop for I equals to 0 till K equal to K. K is inclusive. And for a certain I, we will have choices from among the AC characters, which is less than equal to 10. We have to choose I characters to remove. And let's say K equals 9 and AC is 10. That would be the worst case. Then what are the total number of possibilities we could go with? How many ways are there? We have to choose K things, and we have AC possibilities, and the order does not matter. So AC, choose K. This thing, AC, choose K, and AC, let's say 10 factorial. AC at max is 10, and let's make K as small as possible. The highest value would be 4 factorial and 5 factorial. When K equals 4, that would be the highest value for this thing. And yes, 5, 10, this would be 10 into 9 into 8 into 7 into 6 divided by 4 factorial possibilities, which is just 4 into 3 into 2, and 3 to 6, 4, 2, 10, 20, yeah, 20 into 9, 6, 64, 63, 120, 126, 0. That is not very big. We can handle this. We can handle this. We can brute force. We can brute force. We can brute force. Okay, we can brute force. We can brute force, and that is nice. N and K, taken N, taken K, and also the strings, string A and B, taken A and taken B, and also let's find the number of distinct characters in A and the number of distinct characters in B. We can do that by taking a set in char A and char B. Does the number of characters in B matter? No. Yes. For char X or C in A and CA, number of characters in A is 0. If not char A dot count of C. If C is not in A, if C is a new character that we have not seen, then char A dot insert C and count of characters will increase. Now, if we have K greater than or equal to CA, then C out long N can be very big. N can be very big. So long response is equal to N into 1 long into N plus 1 divided by 2. And else, if that is not the case, or we can just return after this point. Now we have to go through if we are choosing I number of characters from the possible K number of characters that we could choose. Right. Now we are saying that we are removing I characters from A. Now we have to see which characters are we removing, and the total possibilities of characters which we could remove is char A. Now let's go through a permutation. Yeah, vector char possibility is char A dot begin and char A dot end. These are all the possibilities of characters which we can remove from A. And we among these we have to choose I things. So we can just int that is permutation. Int x equals to, we have to choose a subset as x equals to 0 and x is smaller than 1 left shifted by pos dot size and x plus plus. Now if x dot this pop count, I think LSB start line D x dot or is it like pop count dot x? What is the pop count function? Pop count in C++ function std pop count n bit built-in pop. Okay, yes, built-in pop count. Built-in pop count for x equals the number of characters that we are choosing, which is I. built-in pop count. Yeah. Then we do have a subsequence. Okay, and which are the characters that we are going to choose? We do not want to go through the vector and look it up. It is just going to take 10 steps, but let's say here long response is initially 0. Now we have at this point two things fixed. We are choosing I distinct characters to remove from A, and X is telling us what are those distinct characters which we are going to remove. You prepared for ICPC? Nope, I haven't prepared for ICPC, and maybe I will join ICPC next year. That would be nice, pretty cool. LSP stop. Okay, pop count. And okay, now we have two things. We have like literally we have everything that we need. We have I, which is how many characters from AC number of characters that we are going to remove. And also we have X, which is telling us, which is a subset telling us which characters from AC, different characters that we are going to remove. And let's go with that. So for int I, nope, not I, int j equals 0, j less than n and j plus plus, whenever we see a character that we are going to remove. And also one more thing, we need to see how many characters in a row there are which we are going to remove. We can use one crazy thing. For int L equals 0, R equals 0, and R is smaller than N, L equals R. This is one pretty cool thing we can use to find limits for R is smaller than N while, not for, while R is smaller than N, and either the next character equals uh, A R A R equals B R, then we can increase the range, or the next character in AI is one of the characters which we are going to remove. So how do we check if AI is among the characters which we are going to remove, which are in this X subset? Hmm. Which are in this X subset? We can create a set and ask the count, but that is not very good. We can create a function and that would take at max, because the maximum length for pause is 10. We would just have to like iterate 10 times, right? Yeah. So you can write a function bool is included, and this will take in X, an integer, and a vector of characters. Reference, let's say pause, all the possible characters that we could choose, and also a character star C, and we are asking, this is the bit mask that is representing our subset, and this is the thing on which we have our subset, and C is in the set. Now int p equals false for int I equals 0, I less than false dot size I plus plus, and now if false I equals C, and not just that, but also right, the current character is one of the characters which is possible to choose, and the bit which is representing this character is also on in X, and one left shifted by I and X. If that is true, then return true. And we don't need this, we can just return false. That is kind of nice. Is included. We can ask is included X false, and the character that we are talking about is a. If that is the case, then we do R plus plus. And now aug long C response, current response is something. And this would increase the current response. C response plus equals the range is L minus R divided by 2. The range is L minus R divided by 2. So let's say a range is L minus R minus L plus 1 plus 1. Shit, what am I doing? R minus L plus 1, that is the range, and this will be increased by RR into 1 long to make this a long thing. RR plus 1 divided by 2. Yes, and after this is maximum C for this. And at the end, output the response. Okay. Shit. Let's 66. Shit. I will have to go to the washroom and I will be right back in a minute. What is the work? Built-in, please tell. Okay, built-in pop count tells you give this function integer, and this function will return in the binary representation of this number how many ones there are. For example, 5, you write 5 as this, and if you call the pop count function on this, this is the binary representation of 5. If you call the pop count function on 5, this will return 2 because we have two ones here. And for something like 4 or 8, which is the power of 2, the function will return 1 because there is only one up bit in the binary representation of that number. How much question we solve daily? Anyone? Shit, Tom Jerry, hello. Tom and Jerry. Well, on the stream, I have till now only solved one question today, which is not very good. One question is not very good. But yeah, my target is generally to solve 10 questions, which I made just yesterday, but not all the 10 questions on stream. Some questions, as many as about 4 questions on the stream, and all the remaining questions of the stream. And there is something wrong with this question. This is the second question for the day. And the stream has been going on for 3 hours already. That is, nah, that is unacceptable. Okay, let me go to the washroom. I'll be right back. Let's solve this one. There is something wrong with our implementation. I think the idea, the algorithm which we are trying to implement is correct, but the implementation is wrong. Why are all the wrong answers similar to each other? Let's follow one of the test cases. Let's say this one. Here the answer is wrong. Here, okay, we have three distinct characters and we can only change one character. Okay, okay. So we will go here and initially our res equals 0. When equals L or okay, when R, okay, here we can only change one character and that can be A, B or C. So our vector pos in this case, if we do cout pos, I have some debug code here. One test case, as one test case where n is 3, q is 1, and ABC, ABD. ABC, that is amazing, but why is it coming out twice? Okay. Why is this coming out twice? This makes sense when I equals 0 and when I equals 1. That is why it is coming out twice. And let's see, for I equals 0, when we are not changing anything at all in that. Okay, we begin from here, let's say. Answer for this much should be 3. Let's output cout. Yeah, for this parameter, cout c res. Not here. CMP, one test case where n is 3. We can change one thing, and A is ABC and B is ABD. Okay. 10 10 is not even possible. 10 is not even possible. C res starts from 0. R is less than n, L equals R, while R is smaller than n, and A R equals B R, right? And okay, what if, or this is one of the elements which is included. And do we know that L is pointing at a place which is either same or included? Okay, we have to fix L. We have to fix L. While L is smaller than n, and we have either one of these conditions true. and none of these conditions true. That is, AR is not equal to BR, and we have is included false. In that case, L plus plus. And there seems to be like more brackets than required. Okay, cool, cool. And whatever L is, we will do R equals L. We have one test case which has n equals 4, k equals and n equals 3, k equals 1, a b c and a b d, and again wrong. Wrong. Okay, so what are the values for L and R that we have? L and R, what are the values for L and R? See out L, see, then a space, and then R, and then maybe a new line or a semicolon. Not here, CMP, one test case, P1 ABC, ABT. Let's see, 0 and 3. Think this function might be wrong. This function might be messed up. We have X, which is representing our subset, and we have pos, a vector of characters, and we have C. Yeah, and we are asking if C is one of the characters in pos, and if it is this I character included in the subset X? If it is, then return true, otherwise return false. And why are the initial values? Let's also output before this cout X, cout I, the number of elements that we are using. I, and then after whatever is after 1, B1, ABC, ABD. I is 0 when we are not choosing any subsets, then how? Mm, shit. And this has to be -1. That is one thing. Shit, that was wrong. Hello, big brute. Can anyone please help me solve my coding problem? It is in Discord. Okay, someone can help you. Maybe I will look at it after the stream. This is my code. Can help me? And I'm not able to remove the scroll bar when I click on add. Okay, that is something related to web thing, because I am because my name is supposed to be Walrus, and walrus in Greenland there are walruses. And yo, Tkinter Python. Yo, how are you? How's everything going? Shit, we are above the 40 minutes mark. That is bad. And I think this was one of the problem. The way that we were calculating the range was wrong. One test case, 3, 1, A, B, C, and A, B, D. And 3 is actually correct. I thought this might work. Okay, it is misbehaving for a few things. For the first one, the answer is it should be three. Yes, it should actually be three. See out, see risk. Okay, see out, I, space, see risk. We have one test case, P1, ABC, ABC. When we are, that is kind of wrong. That should not be. Yo, I need urgent, please. Okay. Can someone, I don't know, T-Kinter? Does someone know T-Kinter? I don't know T-Kinter. And yes, and this is the question that we are trying to solve here. This one, if someone just joined. Okay, we are almost there, and I think this is fine. We are putting L to the right thing, to the right task, while L is smaller and AR is not equal to BR, and we have this current character AR is not one of the characters in our current subset that we are choosing. Okay, okay. And then we initialize L to that R, cool. And then while R is smaller than L, either the current characters are equal to each other or is what if L equals to R? What if R equals L? R will not equal to L in any case. R will at least increase by 1. Yeah, R will at least increase by 1. Either the current characters are equal to each other or AR is one of the characters that we are going to change. If that is the case, then do this. Okay. L 1, B 1, maybe C, maybe D. And these are the choices that we stand by. This is okay. L is starting off at the wrong place. L is actually starting off with the wrong place. This should be false for the first case itself because both are AR and AR. Here we are changing L. Hmm. 3333. A, we have one test case, 3, 1, ABC and ABD. Okay. Now, I when we are only choosing we are when we are not choosing any element, then L and R equals 3, and that is not, that is right. That is shit. Okay, something is wrong. See, when we have n equals to, seems like there are like multiple things wrong. Look, build body. My no, uh, no. I don't. Yeah, I just work out a little bit. Does C++ have any advantages over Python for competitive programming, or is it just a preference? Yes, there are a lot of people which use Python for competitive programming. You can go with anything you want. I chose C++ because C++ is more complicated than Python, and C++ is, yeah, more difficult. It has a lot of things, and if I can understand C++, then I would be able to understand a lot of languages. Rust would feel easier when I will be learning Rust the next year, and yeah, Python would be like child's play after C++. So yeah, that was the mentality why I chose C++. And also the support for C++ in competitive programming is quite a bit. So that is also nice. And this thing is wrong. When n equals 2, 0, 1, 2, r should be actually equal to 2 in that case. So 2 plus 0 and 1. When L is at index 0, R can be here or here. So two possibilities. And when L is here, there is only one possibility. So, yeah, and the size is 2. So 2 plus 1, answer is 3. But that is not what we see. Wait, we do see 3. Here L is starting from 0. L is A, B, C. This is one string, and A, B, D. This is another. L is starting from 0, and R is also starting from 0. When we are at, these two are same, these two are same, these two are different. So in this case, is included should return, should exit. L minus R, that is the range. Shit, that is the range. And not just that. Not just that. There are other errors. Let's see. When we have one test case, 4, n is 3, 1, and we have ABC and ABD. Answer is 6. That is correct, but this is wrong. This should not be 6 here, and this number should be equal to 2 and not 3. How is it equal to 2? When R equals 2, we see that these two are not equal. So this thing is false, but this thing is returning true. y. Here we will have x equal to 0, built-in pop count of x equals I. When x equals 0, that is something, yes, and yes, okay, cool. This function is taking in x, which is this function is taking in x, which is representing, okay, shit. Okay. Yes. Uh, see out x. Let's just see which x's we have. X, x, and yeah, problem. 1 test case, 3 n and a1, abc, abt, and x equals 0, 1, 2, 4. That is amazing. That is like absolutely amazing. So x is changing as you want it to change. That is very nice. But why is r going till 3 here? That is wrong, completely wrong. So when x equals 0 and shit, it it was supposed to be and instead of or. Now I suppose answer should be correct. Correct answer. Accepted. Shit, that was a very stupid mistake. It took us 1 hour to do this question. Let's see. I think this should be correct now. This should be correct now. Okay, let's go. Let's go. This should be correct. This should work. This should work. We are doing brute force. Brute force is nice. We can also afford to do brute force in this question. So that was a nice thing. And we are actually using quite a few things in this question. We are using bit masking, pop counting. There are multiple things. Pop count and bit mask. That is nice. And also the concept that we could use brute force, which we were able to decide here when we saw, yeah, here we calculated the total maximum things that we would have to do. The maximum things turned out to be this number into 26. Yeah, some number that we can afford, so we should not get TLE error. Yeah, so brute force was possible. Bro, are you solving all the questions of code force till 2000 or some selected questions? I'm solving accepted, cool, accepted in 1 hour. 1 hour is not good. I'm solving all of these questions from this sheet. 1 hour. Refresh. And yeah, till 1900 we will keep solving questions and hopefully we want to get better at this. Now, as to the analysis of this question. Analysis. This question is actually using quite a few things. Here in this part, we are using bitmask DP, not bitmask DP. Here we have a subset. And this is the way how we traverse through subsets of particular size. And this, if you go to Competitive Programmer's Handbook and go to bit manipulation, this is right there. Bit manipulation, bits representing sets. Yes, pop count, And yeah, this is the way. The following code goes through the subsets with exactly k elements. And we are going through a subset with exactly I elements. So yeah, this book is very good. This book is very good. If you completely read everything from this book, I think you would be able to reach 2000. Yeah, because this book is pretty cool. Cool. By Mr. Antti Laaksonen. And the question is lost. Right. Flexible strings. And these are all string questions. This was based on a string. This one is also string sequence. This also seems like to be a string question. Okay, as to the tags, I think bit manipulation, subset bits, and constructive algorithm, strings, and bits, brute force, bit mask, yeah, bit mask, bits, strings, but no constructive algorithm. Instead, we have brute force. Yes, we are using brute force. That is nice. And as to the solution of this question, this was division 2, question number 3. That is nice. Flexible strings. If we replace all characters of A, we can transform the string A to E. So replacing more characters is always beneficial. Shit, we don't even have to go through this. This was kind of stupid. Shit, this would still work. Yeah. And this is much faster. Submit, 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 submit. And it would be much better if we replace the I with K. We are only using a subset of size K, in which we are using K elements out of AC elements. And that is much better. Are we using I anywhere else? I don't think so. Cool. And this should still work. And this will be much faster than the other one. Shit, that was actually pretty stupid, the earlier code. And this should be much faster. This one took um, 1 second. And this one should be a bit faster. Let's read. If we can replace all characters of string A, we can transform the string A to string B. So replacing more characters is always beneficial for a fixed string A and another string B if the answer is xi for ki for another string B. For a fixed string A and another string B if the answer is xi for ki and x2 for k2, where k2 is greater, it can be shown that xi is always less than or greater. Yeah, so this just says if we have the ability to change k number of elements, we should replace k number of elements always. And this is much faster. Look at that. The difference is quite a bit. Yeah, less than half the original time. That is to say, we can safely consider the size of the set Q to be maximum of k or u, where u is the number of unique characters in the string A. Now we can generate all possible subsets of characters from k to u. Obviously, we won't take the characters that are not present in A because they have no effect on the answer. There are many ways to generate the sets like backtracking. Nope, we do bit mask. What we did is bit mask. I don't know about backtracking, etc. If we can calculate the number of valid pairs for each set efficiently, the rest task will be just taking the maximum of them. Yeah, this is simple. This is like exactly what we did. Not simple, but just what we did. And now we can move on to the third question for the day, and that would be nice. That not would be nice, it is nice. Wait, this is shit. Einstein. I'm scared. Einstein and who is this? Richard Feynman? If this is actually Einstein and Richard Feynman, that would be pretty cool. Petya and his friend robot Petya plus plus. Shit. This is robot Petya plus plus. Rank is 179. That is nice. Let's go with this. 40 minutes would be the target. And yeah, 40 minutes would be the target. And this would be the last question for the day. And yeah, 40 minutes. Let's go. Petya and his friend robot Petya plus plus like to solve. One day Petya came up with the numbers n and x, wrote the formula following equality on the board. X and n plus 1 and dot 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 till m equals x, where and denotes bitwise and, then suggested his friend Petya find such a minimal m greater than equal to n that the equality on the board holds. Unfortunately, Petya couldn't solve this problem. He asked you for help. On the way, can you solve the resolved problem? Okay, minimum m, and this is and. So we are always losing bits. We are always losing bits, and n has higher we will not gain bits. We will always lose bits. So first we will take XOR of n and x, and if the XOR is equal to 0, that means n we can just take equal. If n equals x, then m equals n, but if not, then that would mean, wait, it is also not possible in some cases. So what do we output -1 in those cases? Right. N can be very big and x can be very big. For every test case, output if the equality does not hold for any m, output -1 instead. Okay, this seems like this should be very doable. Long n and x, c in n and x, and then what do? We have two numbers n and x. So we have a few cases, right? Yes, we do have a few cases. We have two numbers n and x. Cool. If since binary search, shit, yes. Our equation on LHS is n and n plus 1 and n plus dot something something. Yes, and if we take a prefix of this like this and then this, if we graph a function, this is a monotonously decreasing function, because let's say we are taking and of n with itself when we are only in like when m equals 1, m equals n, then we are not taking and with anything and our value is initially equal to n, and when we are taking and of n with n plus 1, the value might decrease or remain same, and same for all the things to the right, because whenever we take and of a and b, this number what we get is smaller than or equal to a or b both. This new number is going to be smaller than both of the numbers or equal to any one of the numbers. That is good. this is monotonously increasing. So we can say we have dx, which is dx equals m minus n, and the lower limit for dx belongs to the range 0 to what would be the maximum value m can have? I think the next power of 2. Like if we represent n as some number some number in binary representation, then the maximum value of m, which could actually be the answer, is going to be, like, let's say there are k characters in this, then the maximum value of m is going to be 1, and then k number of zeros. So we have the lower bound and we have the upper bound. We can work with that, but what if n is very, very big, like exactly at the limit, right? Exactly at the limit. Then what we are going to do? Because the next power, yeah, then we can say m, the right limit for m, we can show that if required m exists, it does not exceed this number. So okay, minimum of this or the next power of 2. Yes. Yeah, cool. Long L equals 0 and R equals, let's have in K equals 0, and while one left shifted by K is smaller than N, and this one is long, we will do K plus plus. And if equal, then also do this. Yes, then also do this. Now we have K and R equals 1 long left shifted by K. Yeah, let's just see if this thing works. And we have the left limit and the right limit. But before that, we will test the edge cases. Not the edge cases, special cases. If x is greater than n, then nah, see out -1 with a new line and return. Else, or if, you know, everything else will be handled. Everything else will be handled. We have our left limit and our right limit, and r plus plus. R is not equal to the right limit. R is equal to the r minus equals n. Since our number dx is going to represent how much n is increasing by. So now we have while our range, and we think we should also say if shit, this is not binary search. This might be binary search. N is increasing, N is decreasing, but then How do you find out that value? That is given a certain value of m, how do we find out what would this function return? This thing return. That would a bit would only be up if the next bit is okay. We can compare x and n bit by bit and see which bit we want and which bits we want to remove. Yeah, we can compare x and n bit by bit. We will bit by bit compare. We That is kind of crazy. Let's go with this 20 and 16. Uh, x is 20, x is 16 and n is 20. How do we represent these in binary? 16 is simply 0, 1, 0, 0, 0, I think. 1, 2, 4, 8, no, one more 0. That is 16. 1, 2, 4, 8, 16. Yes. And 20 is 0, 1, 0, 1, 0, 0. That is 20. And when we compare these two bit by bit, this, and we will also keep creating our answer. So this bit is 0 in both and same. So we don't change this bit. And also this is our x and this is our n. So we just copy this from n. We get 0 here. This is also same. So copy. This is different and this should be 1. This should be 1. And since this should be 1, yes, only in this case, yeah, we want this to be 0 and this is 0, so this is 0 and this is 1, so this is 1 and this should be 1. This number is smaller than the original number. All we have to do, okay, yes, this is this is exactly equal to x. Yeah, this number will always be exactly equal to x. Uh-huh. What we have to see is x cannot, first we will check x cannot have a 1 bit where n does not have a 1 bit, where n has a 0 bit, because we cannot create a 1 bit. That is nice. And second, when we have made sure that x has a lower amount of 1 bits, and also the places where x has a 1 bit, n also has a 1 bit, then what we'll do is we will take x and we want the next number to be bigger than this. We will take the smallest 1 bit in n, such a bit which is supposed to be 0 in x, and no, 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 no. We'll take the highest bit that we are, that is on in n but is off in x, and then we add a 1 to the left of it. Then we add 1 to the next 0 position. Okay, cool. That that should work. That should work. That should work. We have n and x. We don't need all of this jargon, and we don't even need this. We will iterate. We will iterate. How many bits we have? We have I equals 0, I less than 63, I plus plus. Now, what do we need to remember? We need to remember the highest bit that is off in X but is on in N. Okay. Current bit in N and in X. Bool current bit in N is one long left shifted by I and N. Bool current bit in X is one long left shifted by I and X. Those are the current bits in X and Y. And if current bit in X is true, is true, and it is off in N and not Cn, then C out -1. And yeah, C out -1 have return from the function. If that is not true, if that is not true. Now, if current X bit equals current N bit. Now, either both are 0 or both are 1. If both are 0 or both are 1. If both are 0 or both are 1, we don't care. Yeah, we don't care. We don't care. We care when they are different. Now they are different here, and we know that they are different, and Cx is 0 and Cn is 1. Let's say big equals 0, 9 big equals I. The ith bit is on in Cn and off in Cx. And this is the biggest bit that has such a state. Biggest bit that has such a state. And we will initialize this number to -1. Yeah. Yeah, such a thing. And after this, if we have already not exited the function, we know we have to from X in X we just have to turn on one bit, which is going to be on the left of big, and it is supposed to be off in X, the first 0 bit that is left to big. So for int I equals big plus 1, I less than 63, I plus plus, and if not I one long left shifted by I and X, this bit is off, then we do X plus equals one long left shifted by I to turn this bit on, and we break and we see out X. Okay, wrong answer. Here we say 11, but we should here like the case, yes. If initially we have if n equals x, then C out or n does not matter. We could do this, or yeah, we could just check if b equals -1. If big is not equal to -1, only then do all of this, and here we can avoid this and make this thing -1, and now answer should be correct. It is correct. Let's submit. Wait, this is like much faster than 40 minutes. That is cool. That is cool. Bit manipulation, bit manipulation. Even though we went on a wrong route at the start, this is good. Well, this works. What could be wrong? Current bit in N and current bit in X. Overflow. 2 to the power of 63. Big is the bit that is of biggest bit that is off in CX, the answer, but is on in this. Overflow? Is there a overflow error? Sta- uh, uh, No, it might be overflow. Let's see. Yeah, it might be overflow. No, doesn't seem to be overflow. Expected -1 found 5. Yes, we are messing up quite a bit. For test number 8. 1, 2, 3, 4, 5, 6, 7, 8. This one. 3 and 1. We want to convert 3 into 1. We can do that. Wait, we got wrong answer on 8. Test number 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 into 1. We can convert 3 into 1. What is wrong with that? N is, the first number is 3 and the second number X is 1. 3 is 1 1 in binary and 1 is 0 1. We can take, but we, shit, okay, yes. We are taking and of all the numbers in that range, which includes 4 and everything. I think after this we can just, yeah, after this we can just iterate from n to this number x. How big can the difference actually be? Because the difference can be actually pretty big. We just, okay, this is the best answer that we can have. This this thing is the best answer that we can have. All we have to make sure is if we go any higher than this, then no, it is not going to work. Yeah, the answer is not going to work. But all we have to make sure is that every number between this x, let's not call this x, let's say long n equals x, and here replace, substitute x with m, and here do the same thing. M. This is the best M that we have. All we have to see is if we take and of all the numbers between N and M, the answer still holds. That would only be if all the numbers between N and M have on bit for all these values in which X has a on bit. In this case, N equals 1, 1 and X equals 1, 0, 1. X equals 0, 1 and we have M equals 1, 0, 1. And in this range, we have, first of all, we have 1, 1. This is not 11, this is 1, 1. And then we have 1, 0, 0. And then we have 1, 0, 1. And this bit should be 1 in all the numbers in this range, but it is not 1 in this number, so wrong. When are we turning any bit in X? Yes. Because we cannot just go from the range N to M because the gap can be very big. Gap can be as big as 10 power 18. So we don't do that. I think there has to be a binary thing here. If if let's say this is X and this is N and we are at some ith bit and I want to turn this bit off. I want to turn this bit off. I can only turn this bit off when I have gone through all the numbers, and this should not have any on bits to the left. Yes, this should not have any on bits to the left of this. Yes, this should not have any on bits to the left of this. If this bit is on and this bit is off, then this should not have any on bits on the left because this will not be preserved. Because in the next, I want to make this 0. When I want to make this 0, I will make all the bits to the right equal to 1 and then plus 1 to this so that everything becomes 0 here and this one also becomes 0 and we have a 1 here. And now this one is 0. So if there is such a case where in N I have a 1 bit and in X I have a 0 bit, there should not be any 1 bits in X before this. Okay, so that is one condition and that must be true. What are the other things? There must be other things. When we have a 1, 1, then we don't want to change anything. When we have 0, 0, then also it is cool. And when we have this, yeah, this condition has to be true. Okay, and let's say, yeah, that is the only thing we care about. That is the only thing we care about. And here, big is the biggest bit that is on. It's also have a thing called pos. P initially, let's say equals false, or let's say P is equal to true initially. P equals false. Break, and if big is not equal to -1 and and still possible, then we do this. We will have two for int I equals 0, I less than big I plus plus. No, 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 no. Yes, 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 yes. Every bit that is to the left of big should be of, yes, if bit, if the current bit in n, which is 1 long left shifted by I, eh, x, the current bit in x is on, then P equals false. Yeah, cool. C out, depending on P, if P possible, then C out M, otherwise -1. Just work. And also, when we have two numbers, only one test case where where n is equal to 3 and x equals 1, we should get -1. -1. Okay, this looks good. Shit, without the test case, this would have been very difficult to figure out. Shit, actually, this would have been very difficult to figure out if we hadn't looked at the test case. And this would be the third question for the day if this is actually correct. And it has been 4 hours and 12 minutes. That is quite a lot. Okay, 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 okay. Okay, let's not look at the test case. I equals and when are we checking x is bigger than n? Yeah, if x is bigger than n, then no, answer is not possible. We cannot have an answer. Cn, current bit in x and current bit in n. Yeah, if at any point we have that the current bit in x is on, but the bit in n is off, then answer is 0. Yeah, P equals false and break. Okay, okay. B big is the biggest bit, largest bit, which is off in CX and on in CN. And all the bits to the left are like more significant than big are same in N and X. Shit, okay. If we do turn this bit off, okay, so on the left we cannot have anything on the left, like if the big is pointing to some bit in X that is off. On the left we cannot have something like this, a bit that is on. That is wrong. No. But on the left also, I think, since in the same position as big, in the n we have this as 1. And yeah, whatever the case is on the left, we can handle it. But on x, we cannot have a on bit. That is true. And when we do make this bit off, we will add 1 to this, and the next bit will become 0. And when the next bit becomes, if this bit cannot be 1 in x, yeah, 0. Answer for this is false. Answer for something like this is false. Yes, because when we add 1 to this to turn this like off, everything to the left turns off, and that is wrong. So this is one thing. And after this, if the bit to the left, if the bit to the left of big, that let's do after this big plus plus, this big plus plus bit cannot be on in x. This cannot be on in x. If one left shifted by big and x, then p equals false. This bit cannot be on in x because we already know if we cannot have a condition in which we have something like this, right? We cannot have that where the bit is on in x but off in n, on in x and off in n. So if it is 0 0, then it is okay, right? When we add to this thing, we have no precursions or precautions or yeah, consequences on the left. But if this bit is on in both, this will become 0, and that is bad. This should be better. Let's see. That is a lot of bit manipulation. QWERTY. Wait a minute. Just let me. Okay, this is working. Hopefully, this is correct. And this. Okay. Shit. I think this is because of big became very big. I This might actually be a like error. Yes, bro, I have tried to complete. Okay, bro, retracted. Bro, I've tried to complete web development as much as possible, but you cannot really complete it fully. So I want to ask, what should I do next? I am 17, so I have time. Yes, you have a lot of time. You are just 17. Really complete it. So choose big projects. If you want to grow your skills in web development, choose more challenging, more difficult projects. Shift too large. That was the error. Choose more difficult projects, and yeah, that is it. You cannot fully complete anything, but I want. What do you want? Choose projects which are more difficult. Just that is one thing. Some language. You want to get better at a language, so build projects in that language. That would be one thing. You want language suggestions. Okay, you are 17, so you have a lot of spare time. You can, yeah, you are not under any pressure to get a job right now, right? So I would say go with C++ because C++ is difficult. C++ is one of the most complex languages. And let's say it takes you 1 year to get better at C++. You can spend 1 year understanding a language, and if you understand C++, every other language would seem like very easy. And that is the like yeah, that is the reason behind choosing C++. If you understand C++, every other language will seem easy. And also, if you can get your hands dirty with assembly language, it is one of the best things. Get your hands dirty with assembly language. Big shift is too big. Long. Let's see. This might be correct. This might be correct now, and it is accepted, and it might actually be correct, and it is correct. Okay, 40 minutes mark. Cool. At the 40-minute mark, we have done for 3 questions. Interesting sequence. 40 minutes. Exactly. Okay, we have only done 3 questions today, which is like less than 4, which was the target. But anyways, today was fine. So you come live every day. Yes, I come live every day. I live every day. Please try to. Yep. And yeah, you are 17. You can like mess around with a lot of things. Do you have a Mac or do you have an Intel processor? That is something. Uh, if you have a Intel processor, then you can mess around with Linux. And yes, you go and get your hands dirty with Linux and understand everything, like whatever you can. And one of the best and one of the most difficult things you can do in your life is LFS. So, can you start teaching C++ live series? No, no, they are much better teachers than me. Yeah, they are much better teachers than me. You have tried development. I would say, yeah, there are much better teachers than me. If you want to understand C++, well, for me, C++ was not my first programming language, so I went straight to the book C++ programming language, this book, and this is by the creator of C++. So this was a nice book. And I don't know how would someone who does not. So uh, do you have, yeah, you have done web development, so you do know what programming is like. So I think you can just jump straight into this book. That would be nice. And whatever you do not understand, you can ask ChatGPT. It's most hard to select and do it for next year. Wait, it's most hard to select and do it for next 1 year. Yeah, that is the conclusion. So yeah, do C++ for the next 1 year or however much time it takes. And the main goal is not to get very big or good at C++. The main goal is to understand things, because since C++ is not just hard, C++ is a low level language. The abstractions are low. If you want something on the stack, if you want something on the stack, here you can have something on the stack. If you want something on the heap, here you can have something on the heap. And if you want to store something in the static location, you can have data on the static side of your program. It is just good. The level of control that C++ gives is pretty cool. And yeah, that is the main goal, to understand how computers work with C++. You understand low level languages. That is pretty good. So maybe you can jump into assembly. And if you are going to jump into assembly, go with ARM assembly and not directly with x84. X, yeah, x86. x86 is mm, CISC. x86 is difficult. ARM is simpler. Go with ARM and then maybe you can switch with x86. Well, I myself do not know x86, I've written only in ARM. Yeah, but yeah, you can get a feel with ARM. If you do not have a ARM processor, then you can simulate an ARM processor. I done bit OS in C++. Bro has done OS in C++, and shit, I also want to do OS. There is the classic book for operating system, OS Concepts by Galvin. What the hell? Yes, this book, Dinosaur book. This is called. This is the classical book for learning OS concepts, and that is nice. C, C is nice. And yes, this would be it for the today's stream. For today's stream, if you have anything you want to ask. Yes. Okay. So shit, bro is 17 years old and he already knows what the OS concepts book is. That is very scary. That is pretty good for you. And your name even is like pretty nice, QWERTY. Shit. Have you watched Mr. Robot? Shit. Why can I not unzoom? Okay. What your name? My name is just Jatin Raghav, like my channel's name. And yeah. And have you watched Mr. Robot? I have a feeling you might have watched Mr. Robot. Bye. Okay. Bye. There is a lag. Yeah. Anyways, yep. That would be myself. Avinash. Nope, you haven't watched. Okay, that is fine. Hello, Avinash. And that would be it for today. And everyone, thank you for being here. That was a nice transition. Bye.